In this video, I want to explain why a direct proof works. So a direct proof, remember, is a proof of the form if P then Q, where P and Q are statements. So we're proving something of this form, P implies Q. And the way you do a direct proof is you assume P is true. So that's your assumption. P is true. And what you want to show is that Q is true. And students have a hard time often with this whole assumption that P is true. They say, hey, that doesn't make sense that you can assume. How can you assume that P is true? And that's a very good question. And I want to answer that now. I want to show you why you can assume P is true. All right, well, it all comes down to the definition of P implies Q. All right. So P is a mathematical statement. All mathematical statements are true or false. So P is true or P is false. Now what happens if P is false? If P is false, then we're in one of these two bottom rows here. And look at what happens. P implies Q is defined to be true when P is false. Right? So if P is false, then the overall statement P implies Q is true. All right, so if P is false, then we know P implies Q is true. So we may as well assume that P is true. Right? Because the only time where things where we have any variation is when P is true. All right, so let me go over that again. P is either true or false. If P is false, then we're in either this row or this row. And look what happens. P implies Q is true. All right, so we may as well assume that P is true. And if we assume that P is true, then we find ourselves, in one of these two rows, these two upper rows. Now, if we show that Q is true, then this can't happen. And so we can eliminate this one, and then we know that the overall statement is true. That's how a direct proof works.